we're just getting started.
Today, I'm joined by Chad Johnson, co-founder and CEO of Grain Weevil. For those of you that don't know what Grain Weevil is, it is a grain flow intelligence robot designed to keep boots out of the bin. The idea for the Grain Weevil robot came from a farmer friend who asked Chad and his son Ben to build him a robot so he never had to step foot in a bin again. And fast forward from 2020 to today and many different iterations, we have Grain Weevil going out to the public. Is that correct?
That is correct. We've fully launched, and robots are ready to go out to the farms and to commercial facilities.
That's awesome. I've been following along with your journey since 2021. You put me in a bin for a little bit to capture some footage, and it was really eye-opening. I've been in a bin when I was younger, scooping, sweeping, all the nasty stuff that nobody really wants to do. And yeah, it's a dangerous situation to be in. I'm glad that you guys are building the product to alleviate that.
Well, we were very excited to have you join us back in the days when you were doing a little bit of video work for the Combine, and we were going through that Combine experience. The funny part is, my son and I had never been in a grain bin before we started. So you walked in with your video cameras with way more experience in the grain bins than we have ever had. But I think that actually has helped us a lot. We came into this with a mission, to help a family friend, and then now that's extended to all farmers and people that work in stored grain. So it's been great to be able to sit back and say, we know how to build robots, but you guys got to help us figure out how to build a robot that'll work in a grain bin.
Right.
And it's been great.
And that was going to be my first thing to ask you, that first time actually stepping into the grain bin. What was that like? Or actually just being around it? Because, you guys originally from Aurora and now in the big city of Omaha, but you were surrounded by agriculture and you hadn't been in the bin.
Yeah, even I grew up in Kansas, and my family farmed wheat, and so I rode in the wheat truck every once in a while, but never got close to. I did weed eat and mow at a grain elevator, but didn't get inside the work. And so, a couple of things stood out. The first time that we leveled a grain bin, it was with a robot. And that was before we had the capabilities of doing it safely outside. So we took all the precautions, we had the masks and the harnesses, and we were strapped to the staircase to make sure that we were going to be safe. And I sat there, and I was probably an hour into driving this robot for the very first time, and I just couldn't help but think of how miserable I was. And all I was doing was wiggling my thumbs.
And you were just standing there,
and I
right?
was not even scooping. I wasn't doing anything, but it was just hot and it was gross. It was no fun to be in there testing a robot. So it kind of really struck me, that these farmers are doing things that nobody wants to do. And that's what really keeps driving us towards, yes, the safety and keeping you out of bins so we can avoid getting entrapped. But as the farmer goes in there 6, 7, 10 times a year, the risks of lung disease and just miserable work environments, those are the things that we can make our lives a lot better by providing technology like this.
Right. And those first iterations, like the one that you were talking about, they're not like the robot that we see here today. You've got them up on the wall over there. And so walk me through that first robot. What was that like? You guys clearly you had an idea from the beginning that kind of stuck, especially with the auger drives, but walk me through that.
Yeah. So that actually wasn't where we started. Which now you kind of smack your head and say, duh. No, yes, you should use augers to drive a robot in grain. But, when we first started tinkering, we were thinking about like a snowmobile type track, or we even tried like a paddle wheel type drive system. We just tried some more traditional ways to move on the grain. It really hit us like the late fall of 2019. One of the weekends, Ben was home from college, and we were like, they move grain with augers. Do you think we could move a robot with augers? So we started doing some research, and we found out that there had been some, like 1950s swamp tanks that used big old floaty auger drives, and it was really good because we were able to use some of the knowledge that they had gained, but they had to be like these massive machines, and that would never have worked in the grain. The size and the weight really matter on how well it moves on grain. So each of those iterations like that, the first one that worked, so maybe you'd be able to throw up a picture of the history wall,
sure.
But there's 3 of them up there that were like nothing but learning. It took them out to the grain bin and they sat there and did nothing.
Yeah.
And then the first orange one with the duct tape on it, and it kind of scurried around on the surface. But I think the most fun aspect of that was, Ben and I were super excited about our robot working, and that farmer, Zach Honeycutt, that challenged us to do this was also standing up there at the top of the grain bin looking in the door. And we all 3 started jumping up and down and super excited. And we were excited the robot worked, and he was excited that the possibility of that there was a tool that was going to help him.
Right. Yeah. It was just that opportunity that was presented. And that first iteration, I'm guessing you weren't really, the first iteration that worked, wasn't really necessarily moving grain, but you were moving on top of the grain, right?
Yeah, and it used 2 Milwaukee batteries, and that lasted for 45 seconds.
Okay.
So those of you that use any of those handheld drills and the 18-volt systems, you can use a drill for days.
Right.
So it was a learning, shocking moment.
Right.
That we drove, and it did. It just scurried on the surface. It did not move grain at all. I was like, why did it stop working? It only lasted for 45 seconds. What did we break? And it was nothing. It just used up all the juice.
It just had that much power
it's
consumption.
how much it takes to move. So that's where the iteration from that little tiny orange one to this one, a lot of work on the battery systems and the drive systems, and so it's been a really fun engineering project.
Right. And it's also really fun that you're able to do it with your son, right?
Yes.
Let's dive into kind of the modern day robot that you've got here. Many things have changed, especially since I've been working with you and just 5 years now. But the first thing that always jumps out to me is the height of the robot. The robot is significantly higher up off the right now off the table than what it used to be. So the clearance is different, as well as, you added the shovel on the back and the wings on the side. So
so each of the iterations and the history wall helps us just tell the story of, we started looking at drive systems. We actually started with a belt drive, and then had all kinds of problems. It probably would have worked a lot better if we'd had a real engineer helping us at that point, but we didn't. So we moved to these exterior right-angle gearboxes. And in each iteration, we looked at different battery packs, all looking towards how much power they could provide, how fast they could recharge, and if they would ever be safe or not. And so we have 10 robots up on the wall that would never have been safe to sell.
Right.
We're using off-the-shelf LiPo battery packs that you use for your remote control trucks and those kind of things. And they're just never going to be safe enough to go into that grain dust environment. So the battery pack pretty much dictates the size of the robot. And so as we started to dig through the battery pack, we started to build around that. The battery pack required us to kind of bring the augers underneath of itself a little bit more. And then that also made it tip over a lot easier.
Right.
So that's where we added the wings. So each of the iterations, different augers, different drive systems, different batteries, then the wings, well, then we just weren't doing enough work. So that's where that shovel come in. It's like if we're going to level a grain bin even at the same pace as a human, you need a shovel. So that mud flap on the back, if it drives forward, it just flaps in the wind. When you drive back, it engages in that grain and really starts to push. And it surprises a lot of people how much grain this device can push.
I mean, when I'm looking at it and when it's running, it really does seem like every time that you're moving backwards, it looks like at least a scoopful of grain at a time. That's what it looks like to me. And then you get into the flow of the grain. Once you can start getting that grain flowing, all you have to do is agitate it just a little bit, right?
Yeah, so it's a unique balance between so the auger system and the weight of the robot added to the angle of repose, the slope of the grain, the different grain types, the different moisture. Whether or not we just sit there and spin the augers and move grain, or whether we spin the augers and move the robot. And so the combination of using the augers to both drive the machine and move the material really has a big impact. And then also, that's a huge benefit for how we break up crusts. We're using the same system, so it simplifies. We don't have to have a separate attachment to break up crust. We just use the drive system. And that's really what made it simple but effective. And right now, this iteration of the robot, in most situations, if it takes a human being 1 hour to do the task, it takes us about 45 minutes to do the task. So we're about 75% of the time it takes a human.
Yeah, just developing more efficiency. And I've seen a couple things behind the scenes here. There's always more things being developed. And that just comes from those iterations. You guys have the production model now that is being shipped out, but kind of talk about what's going on in the future, or what are things that you may have tried and then realized, let's pivot and learn from that.
Yeah, so obviously the looks of the robot have changed a bit, and this is a sample robot that was actually our pre-production version, so it doesn't have all the trim pieces on it. We've added trim pieces to the flange stuff here because we needed more attachment points to add other things, whether it's the easy way to put the camera that can now be mounted on the robot. There's all sorts of reasons, and the new trim pieces allow us to be IP65 rated, which means that you can wash down your robot. Which keeping the robot clean is extremely important because it can move from grain bin to grain bin, and you want to make sure that you're not bringing alpha toxins from one bin to another or whatever those things may be. So it just makes it a lot easier to maintain that robot. Some of the other fun things that we're working on with this version of the robot has 2 radars inside the robot, so it can detect the walls. So now the autonomous capabilities can avoid running into things, and that's a big part of the progress that we're making. This robot has every capability of being improved with the autonomous, with what's inside of it. And then when we're ready to make the next step in our unleashing of full autonomy,
Right.
This robot's fully upgradable to all of that. So that's a big push on what's next, is to make it more and more and more autonomous. But the idea behind where we're at now is that there's tremendous value in the human supervised autonomy that's out there. Right? It gets the work done. It does things that humans shouldn't do, and that's exciting for us because right now in the state that it's in, it shows real value, and I think that's the important part above and beyond just the safety aspect of it.
Right. So when I'm online and I'm looking and seeing the videos and everything and how people are interacting with it, there's quite a few questions that people have One of the big question is, how do people actually get it into the bin?
That's that's still the most complicated part of this whole thing. When people ask me how difficult it is to operate the robot, I can teach an 8-year-old how to run the robot in like 30 seconds. Right. It's just intuitive. It's just like a zero-turn mower or a skid steer. Joysticks go forward, it goes forward. Joysticks back, it goes back. The challenge is the process of getting it in and out of the grain bin. But what we have is we have a winching system that goes permanently onto your grain bin, and it pulls the robot up from the ground. You swing it over, and you drop it into the grain bin, and that makes it both safe and efficient to get it in and out, so you can actually work when it's full, when it's half empty, when it's all the way empty. So you can pull the robot in and out all the way from the top to the bottom, which is important aspect of this. It's not just, well, it's only 50 pounds. Can I just carry it up the staircase? Well, no, we don't want you to carry it up the staircase because of the risks, right? It's awkward. The augers get caught on things, so we want it to be a safety aspect. But it's also a very important part of the workflow. As you get the robots in and out, as you need to recharge the robots, that winching system becomes very, very valuable.
Yeah, you touch on recharging. That's another big question. Beyond just getting it in and out of the bin, what does the recharge look like?
Sure. What we like to say is that no matter what your situation, you can run the robot as hard as you want to for an hour. In all reality, depending on the grain type, the moisture levels, all of that, the robot operates between an hour and 2 hours. I was just down in a Milo bin a few weeks ago, and we were running the robot as hard as we wanted to run it, and it lasted 2 hours before it needed a recharge. We pull the robot out of the grain bin, want to do the charging outside as much as we can to avoid any dust issues. Charging is always the most dangerous part of any battery-operated equipment. So we pull it out of the grain bin, and on a 120 standard charger, it takes 20 to 25 minutes to recharge to give you another hour, 90 minutes of runtime.
Yeah, that's pretty quick. Kind of going into when you're talking about speeds of charging and the battery, that makes me think of, the dust. That's another question that people have. How safe is it inside the bin?
So, this is, you go through all the social media and there are a lot of fun questions like, why does it have a light?
Right.
There's also a lot of, assumptions that we don't know that dust explosions happen. We do, right? From the very beginning, from the very first robot, we've always known that we have to build a robot that can pass the Class 2 Div 1 dust explosion requirements. Those are all engineered into this robot. They're brushless DC motors, so there's no brushes, there's no sparks. Benjamin has designed a safety circuit for our electronics that we can, if it gets too hot, it can shut off one of the motors. We can control the current flowing through. Everything is designed for it to be safe. So what we're working on is we're actually getting the certification for that, which we will be the first mobile robot that has the grain dust explosion certification. So we've had to kind of lay the pathworks for that. So engineering-wise, very much all engineered, all built, all designed, all tested in-house, perfectly safe to operate in a grain dust environment. Waiting for that magical sticker from UL that says we agree, and then that's when we can actually get into those commercial facilities who are regulated through the dust environments.
Yeah, and you briefly touched on testing and that you guys are doing testing. Yeah. Kind of what does that entail? That way, people that are going to be using the robot actually understand what this has gone through to get that certification.
Sure. So with our options that we have right now, there are about 17 different tests that we have to pass. Some of those are surface temperatures, all the surface temperatures. Worst case scenario, they disengage all of our safety features. The highest surface temperature has to be significantly below ignition temperatures. So we've engineered all of that in. We've got to do drop tests because we're claiming that the seal of the robot, so everything's sealed up inside. So the enclosure is one of our safety factors, and so the enclosure has to be dropped on a concrete floor multiple times. If we use the plastic version, we have to freeze that to our lowest temperature, and then drop it on the concrete floor 4 times, and it can't crack, it can't break the seals.
What is that temperature?
So negative 20°C, which is about the same. It's well below any temperature that you should be out working.
Right.
But people say, why do you put it? Because we can select the temperature and the way we're certifying it. Why would you put it below 0? Well, we've been out below 0 breaking up ice chunks inside of grain bins. And if we're willing to go out and do that, the farmers are going to get out there and use the robots whenever they need to. And so that's our goal, is to design the robot that can be used. So it's basically from 20 below Fahrenheit to 140 degrees Fahrenheit. So if you're bringing grain out of a dryer, we can still operate.
Right.
So,
and I mean, when I think about the grain bin and I think about the grain being stored in there, I mean, there's people that do it several different ways.
Yeah.
And everybody thinks that they might have their right way, but you guys are kind of developing a intelligence model for how to handle grain, right?
Yeah, so as we started this project, the number one goal, break up crusts, make sure no one gets in there when there's a crust or a bridge. Then as we started to realize the way the robot works, we could level, and we could actually address hot spots and wet spots. So what we started to develop was this idea of we call grain flow intelligence. And all of the best practices from the history of how to store grain, uniform airflow is the best single thing that you can do to maintain grain quality. And the robot gives you the tool that allows you to implement a lot of the best practices that used to only be able to be done by a human. And then it also unlocks a lot of practices that no one's ever going to cone out a grain bin and then go in there and scoop grain into the sump, right? It's just not safe. But we can do that with the robot. So this grain flow intelligence is really about precisely controlling your airflow, your moisture flow, and your grain flow throughout the entire grain storage process.
Nice. And that's something that, I mean, isn't on the top of everybody's mind. The big push is for harvest. And then people, not that they forget, it's always at the top of their mind. It's what they spent all year building up for, was the grain that's in the bin. But once it's in the bin, there typically isn't too much of interaction, right?
So there's been a growing adoption of the grain bin intelligence systems, which are very helpful. They detect when there's an issue, allow you to turn on your fans. But if you really want to address that issue, before Grain Weevil, the only tool that you had to go in there and to spread out the wet spots or whatever was a rake or a shovel, and the human being in the grain bin. So I think that's a big piece of all of this. We're not coming in and we're not replacing your sensor cables. We don't do long-term moisture observations. We can do inspections,
right,
and those kind of things. So it's not like we're really trying to replace any of the things. We're just here to make everything more efficient and make things work better for you. Because in this environment, your profit margins are extremely tight. So every kernel matters, and every bit of grain that you can maintain the highest quality that you can, the better off you're going to be when you do sell your grain. And that's what the robot gives you, the best case scenario for doing that.
Yeah. And just having a deeper understanding of what's happening to your grain. I mean, you're not, like you said, you're not replacing any of those sensors that are out there, but you're working in cooperation with them, and that's something that's critical across the Midwest and especially here in Nebraska. And that kind of goes into my next question: is you guys are developing here in Nebraska.
Yes.
Why is that important to you, and why has that been beneficial to you?
Well, it's one of those things where you grow where your opportunities are, right? And as we started, like you said earlier, we started this in our Johnson Laboratory of Innovation. It's our little robot shop in my backyard in Aurora. When my son was in college, well, he didn't want to move home back to the small town. Who would at that age, right? So we started migrating the robot activities here to Omaha, which has been very, very beneficial to be a part of the startup community. It's statewide, but there's just different opportunities in Aurora versus here in the Omaha area. We're close to a lot of very, very well-respected grain handling companies. We can get to 80% of the stored grain in the United States within 1 day's drive. So the location is extremely valuable. As we've started to grow up, we've started to realize, Nebraska and Iowa, they're the leaders in a lot of areas that impact us, including ag tech. Right. And so we had the combine, we have Invest Nebraska, we have the Grit Road investments, we have the Nebraska Angels. So we have all these parts and pieces. We have an unbelievable patent lawyer who has an ag background. Like all of these things just lined up for us to make Nebraska the perfect place for us to continue to grow. What I would argue, if we're going to go, like on, SAT scores, Boston Dynamics is going to be way above us as a robot team. But if you go to solving problems and having one of the coolest robot shops in the world, I'd put my guys up against anybody. We're really, really good at solving problems. We're really good at making things as easy as possible. And so there's just a lot of unique aspects of, what we call rural innovation. Mm-hmm. It's being able to do what these farmers do and make something out of nothing, as opposed to what they do at MIT and Boston and on the coasts, where they're very intelligent solutions. But we're here, right? We're getting the input. We were out at the grain bins yesterday. Yeah. Right. I mean, that's why it's so important for us to do it here in Nebraska.
Yeah, your proximity to just being able to test in real world environments, as well as not having to necessarily stage, I think is huge.
Yes.
I mean, yes, you can stage it to a point, and you can have some grain being pulled out, and then you go throw the robot in, and then you've got an inverted cone to work with and test that way. But in my mind, you're out in the real world. Your experience with people that have a different ag background than you do really has to be very impactful.
It is, and I think mentioned the honeycuts, and as most people in Nebraska probably know the honeycuts and their family, but I'm going to throw the boys under the bus a little bit. It's actually Daryl, their dad, that gives us so much feedback when we go out to their farm and we do all of our testing. And Daryl's right there, and he loves the robot, and he uses the robot, and he fully engages in the whole process. So it's a lot of fun for us because Zach and Brandon are tremendous, and they're very well connected and have all the resources that we need, and they give us great advice. But it really is. We love when we can go out and pick Daryl's brain.
Right.
Yeah, it's just awesome. And it's not just the honeycuts. It's hundreds of farmers across Nebraska and thousands across the whole Midwest have taken a special liking to us.
Right.
And so they're so willing to give us input and advice. And since we don't know anything, it's easy for us to not pretend.
Right.
Right? I truly, everything I know about grain has come from these farmers helping us see how our robot can impact their bottom line.
And it's directly from the source. And I mean, we just wrapped up trade show season, right? So I know you guys were out at Farm Progress. What was the interaction like with the people there and them seeing the robot for the first time?
Well, that's the funny thing. It's not the first time they've seen the robot, as you know by all of your video clicks that we see from the videos you've helped us make. Like I would say 99% of the people that came to our booth had already seen the robot in the videos. What's interesting is when you look at the video, the robot looks super tiny in a grain bin, right? And we had a 12-foot stock tank full of grain, and we're driving the robot. And I think the thing that surprises the most people is how big the robot really is, even though it's built to fit in a 24-inch hole at the hatch door. So we're not that big, but it does look a lot bigger than what most people think. And I think that's kind of the shock and the realization. It looks small on this videos, and most of our videos show a lot of breaking up crusts because that's the cool video stuff.
Right.
And it's pretty boring to watch 6 hours of leveling a grain bin. So them seeing it in person, them getting to drive it, we hand the remote to somebody, and within seconds they're driving it.
I mean, if they've had any experience driving a skid steer or a zero-turn mower, they can hop right on it, right?
Right, and so it's just really cool to see that interaction. The best part about it for us is, we've been around for, really since 2021, where we've started to get some exposure. But as with all of our old prototypes, I mean, we were just an innovation company. Now we're selling robots.
Right.
So the conversations were so much different at the trade shows. Now the questions are much more about how does this work on my farm? How does this fit into my workflows? When we start talking about their farm profile, it's, how many grain bins do you have? How are you managing your grain now? Where are the places that the robot can give you improvements? And so those are all of those things that we're building into that grain flow intelligence, and the idea of the farm profiles. It's look at your farm, see what practices you're implementing now, all the way from harvest to clean out,
right,
or actually to clean up,
right.
Which some of you have seen some of our teaser videos, but it's all every step of the way. There's some things that you can do to improve the process, and so starting to show people that what those steps are really exciting, because a lot of people see the videos and think it's a one-trick pony. It breaks up crust. Well, it's not. The goal is to avoid that, to maintain your grain quality throughout the whole process.
Right. It's the goal at the beginning was crust, and then now it's, well, let's prevent that. Let's make sure we're not losing any of that crop that you work so hard for throughout the entire year, and B, making sure that you store it the best way that you can. Right.
It is, and it's nothing that we're not claiming that by using a robot, you're going to save this amount of money or this amount of time. We're just saying if you level your grain bins, this is the best practice that you can do, and you can do it with a robot. Yeah. So we have the history of all the best practices, plus a few, like I said, plus a few of those that layering your grain bins is a practice that they've Dr. Meyer at Iowa State University has papers from the 80s about layering your grain bins. Well, no one's going to go in and level a grain bin after every time they put in a truckload. Right. But those are possibilities that are starting to be opened up with the robot. Right now, we tell you, you're probably not going to do that because it still has to be supervised. But if you're harvesting along and then you drop into the bottom, of the creek bed or whatever, and you all of a sudden have a truckload that's dirty and nasty and a lot more moisture than the rest of your grain bin, Well, you can throw the robot in, take care of that before you bury it, and get rid of those hot spots and wet spots in the center of your bin.
And just prevent the
Just
issue
prevent
from rising.
the issue from rising. And the other really cool part of that is a handful of the farms that have robots now have those kids, those 10-year-olds, the 14-year-olds who can kind of have a role on the farm, but not really yet. They're not old enough to drive the trucks so they're finding ways. Well, those guys are allowing their kids to own their grain bins now, because now the kid can come home after school, spend a few hours running the robot and making a huge impact on the family's bottom line, and have real value on the farm.
Awesome.
And so it's a really cool to see that process happening as well.
That's really awesome. And then, I mean, when you were out at Farm Progress, did anybody come up to you talking about different kinds of grains? I mean, here in the Midwest, it's heavy corn, soybean,
Sure.
a little bit of milo, like you talked earlier.
Yeah.
But
Well, so I may have to count on my fingers to help me remember. Obviously, corn, soybeans, popcorn, milo, wheat, rice. What are some of the other ones? Canola. We've been on peas. We've been on oats. We've been on pistachios. We've been in sand. We've been in salt. We've been in dry fertilizer, alumina. Like, the list goes on and on and on. So every grain we can operate in and have an impact. And then most other granular materials, we start to run into some challenges when you start to get like the cakey soy meal,
Right.
if it starts to cake. But we're getting better and better at that as well. So it's pretty cool. Anything that you can store in a grain bin or a silo or even in a pile, the robot can have an impact on your management of that process.
yeah, I've always just been curious about like the large piles and like when I think of almost like the shipping, like the barges,
yeah.
like how are they actually maintaining it? And I foresee Grain Weevil helping out with that in the future.
Definitely have some interest in some different areas of barges and ships. It's about balance. So like the barges, it's not necessarily getting more in the barge, because you can only have a certain amount in the barge before you sink below that
Right.
that line. But it's about balance, right? It's about leveling that out so that you don't have the barge lopsided or you have different moisture migration inside that barge. But the large piles, interesting. Last week we found out that one of our trial partners used robots to pull their ventilation tubes. So instead of the humans pulling the tubes up and across the big outdoor bunker piles, they're using the robots to do that.
That's awesome.
And so that was
probably
really
also
cool.
something that you never really thought of that would be a use case right off the bat, right?
Well, considering even after they told me about it, I'm like, what are ventilation tubes, right?
Right.
I'm now explain to me what they're not just underneath the pile. No. So yeah, obviously we're not coming up with all the new use cases because we don't know where it needs to be used. So that's been fun. We've had so many farmer wins. We've got 67 robots out now, and it's so fun to hear about how they're using it and where they're seeing the wins that we kind of anticipated that, like, maybe if you're using the grain vac, the robot could be helpful. But it's significantly decreasing in the amount of time that it takes to clean out a bin with a grain vac. And so those are exciting things that we thought it would have some impact, but we're seeing a really, really good return on those.
Nice. You mentioned it earlier. We dropped a little teaser.
We did.
Kind of walk through the thought process behind that. And I mean, I've seen online it caught a few eyes. It's grabbing the attention, but walk me through that.
So we introduced a robot to break up crusts and manage grain. And That's awesome. That's cool. We love that idea. If it could only clean out this, if it only could sweep,
Right.
For 3 years. Oh, if it could only sweep. And so the video that we did a little teaser with about a month ago or so, we take the robot that you already have to manage your grain bin from start to finish, and then 10 to 15 minutes, you put the tank treads on instead of the augers and a sweeper unit on the front. And so we did a little bit of a teaser, and actually most of the video that we released was the first time that we ever went out. So as part of this fun prototyping process, that is not available today. The value of the robot today is leveling your bins here at harvest, maintaining your quality throughout storage. We're targeting sometime next spring, early summer. You'll be able to buy the tank tread and the sweeper attachments and sweep out the bottoms of the grain bins. And the best part about that is you could be sitting out in your pickup truck, or you bring a lawn chair and sit outside, and you're not breathing in that dust. You're nowhere near that sweep auger. All of those things that are exciting about that final cleanup process.
Yeah, I've done my fair share of cleanouts growing up, and even a couple this past summer. And those 100-degree days when grain needs hauled and you're just not ready to hop in the bin, I'm ready to see that out there in the world. But speaking of the world, I know that there's interest across the world and international markets. It's something that I've seen that it's not just the U.S. that's very interested in this.
Well, I don't know if I should thank Saturn's lens for that or blame Saturn's lens for that. Our worldwide attention is 100% from our videos, and they've gone viral. Brazil obviously is a very important target for us, but I've lost track of the countries that have reached out that have they've seen the videos, and it's not just the agricultural. That's where we're starting to get a lot of the industrial market as well. But yeah, so they see the videos, they're intrigued, and so as a part of our growth process, most of you, if you've seen our website, you've seen that we've started here in the Midwest, and we want to make sure that we're able to provide a good product, a good service. We want to grow intelligently, and it's not easy to do with a brand new piece of equipment that goes into an environment that no piece of electronics should ever be in, right? And it's easy to get excited about going everywhere like Brazil and Canada and Australia, but it's also really hard to manage that growth. So we've got to kind of have some strategic plans around our growth, but we are super excited that we have a local organization that's helping us get our robots down into Brazil. So we'll give a shout out to Ag4Up.
There you go.
Which Joao would be another great person to have come talk to you, and they got a lot of really exciting things. But what the best part about them is they're half here in the U.S., half in Brazil. So they've got boots on the ground in both places, and their job is to help companies like ours navigate the waters of getting into a foreign market. And with their help, we've now found a partner in Brazil that's going to represent and distribute the robots for us down there. So we're just signing that MOU, and we got that process built out for a few robots. There's one robot down there now.
Nice.
Got a few robots that are going to be sent down here this fall, early spring, and then just kind of grow that progression like we've done here, which were a few early adopters, and then a handful more robots, and then some service providers, and then we've released the product. So that's a long process, but it's really interesting because just learning about the ag industry in Brazil and the challenges they have, and they're growing 2 or 3 crops in the same year,
Right.
and so there's just different challenges, but it's all the same,
Right.
right? The techniques of how to take care of their crops. The robot is a huge asset for them. Same with Australia, same with Canada, except Canada is probably the reason we got to have that -20. Those guys
Right.
up there,
Little colder up
little
there.
colder up there. But so we're super excited because it doesn't matter what material, it doesn't matter what country, what location. The robot is proving its merits managing grain.
Yeah. You touched on it there for a second, though. You have service providers. That's the Benesis network.
Yes.
Kind of walk through what the Benesis network is.
So as we started to roll out robots, we want to get more and more robots out starting in the Midwest. And the easiest way to do that to start with was to have service providers that had fleets of robots that could come to your farm and do robots as a service. So last year we added 9 of those. And now, if you follow us on social media, you'll start to see we're just announcing our 10th down in Tennessee. So those Benesis partners have robots, can come out to your farm. They can level your grain bins for you. They'll take care of any issues or crusts that you have, and it's as a service. So that's particularly helpful for us because now we get more and more hours of robot time. Mm-hmm. We get more individual feedback from people that are not our engineers. But then it also allows farmers to see the product on their farm, see it in action, see the impacts that they can have. But then in the long run, the Benesis partners are our sales and distribution network. So we don't like to necessarily call them a dealer network because they're so much more than that, because they'll deploy the robots, they'll do training, they'll be that first line of customer support, and then that'll also be where you can get replacement parts or warranty work or any of the things that go around that. So we're really excited as we've added these 10 companies. They're all small independent ag retailer type companies. Some are farmers, some do drone spraying, some do a few other things like grain bin intelligent system installations and those kind of things. So it's a wide variety of folks, but they all see the value of the robot. They all have the skills to come out and help you. And then there are support network throughout this process.
Yeah, it's super important to have those people out there being able to do the services as well as provide support, because farmers are going to need help initially once they get started. But beyond just farmers, I mean, you're talking about huge flat storage and stuff like that. So those people are going to need support as well.
Yeah.
What's on the agenda here for the tail end of 2025 going into harvest here?
So we have robots available. We're taking orders. So that's kind of the biggest news is they're publicly available now, not just kind of secluded early adopters. So we're building 100 robots right now, and those are ready to be rolled out onto your farm. And so if people are interested in getting robots on their farm, they would just go on the website and find their local Benesis partner. If they're not in one of the areas, they can contact us directly, and we'll either hook them up with their closest one, or we'll manage. We'll be their Benesis partner.
There you go.
And so we're super excited about that, because this is it's that early adoption. It's we know we're not in a spot where we're going to have that full blown selling more robots than we can build, but it's the momentum. And this momentum's building. We've already sold quite a few of these robots. We already have a handful of potential bigger contracts that we're working on. And so it's a really exciting time for us. But we can't rest, right? We've got this robot. We're building the robots. They're going out. We're supporting that. And we're designing our full autonomy system, and we'll be testing that. We've got the sweeper robot that needs to get tested and ready for manufacturing. We got all of these aspects of continued growth to make sure we meet demand. As we all know, that holy grail of buying robots, getting on your phone and saying level my grain bin and text me when you're done. That's the future, and it takes a lot of years to get to that. And so we're already working on all of the what's next to begin providing you value now, giving us a path of growth with the robots that you get now, but then also have the capabilities of continuing to get better and better and better as we grow as a company.
And this isn't just a buy now, upgrade later kind of situation where if you buy this robot, you're going to need a new robot in a year. That's a huge thing for me, is seeing that you guys are committed to this platform, as well as making sure that people can update it in the future to keep going with the autonomy that's coming, with the different attachments, if you guys decide for a different light bar or something like that.
Yes. Yeah. So all along the whole concept was that this is a platform. Now that platform may look a little bit different in a year. The platform may look really different in 2 years or 3, depending on the development times. But this core platform that we're selling now can be upgraded to almost all of those features. There's one dream feature that we have with articulating legs and those kind of things that 2 or 3 years from now the robot might be able to go into cakey materials and silage type materials. But that's a whole nother robot a few years from now.
Right.
But this robot here is upgradable to our autonomy package has about 3 different phases. And each of those phases, this robot's still capable of being upgraded to those different aspects. And so we're excited about that. Been pretty conscious about making sure we're capable of doing that.
That's awesome. So 5 years, over 5 years now that you've been operating, right? Or working on it at least.
Officially, the idea was in 2019. But you know how hard it is for a 20-year-old, 21-year-old to spend any time with his dad. So 2019 and 2020 were pretty much piddling around on a few weekends a month, or maybe not even that often.
Just having some fun with it, though.
Yeah, it wasn't. We started the combine in 2020. We went through Ag Launch in 2021, but we really didn't launch this company until Ben and Zane graduated from UNO in May of 2021. So yeah, we've been around. The first robot worked in March of 2020, so we kind of call that our birth date.
There you go.
So yeah, it seems like it's been 50 years, and it seems like it's been 3 days,
right?
All at the same time. So
a lot packed in 3 days, though.
Yes, a lot packed. If it was 50 years, but right. Yeah, no. So yeah, we've really been working on the project for about 5 years.
And I mean, that probably gives you enough time to think of the hindsight's 2020.
Oh yeah.
Is there one moment that kind of stands out to you that you realize, it's just the light bulb moment that, if we would have thought of this a year earlier, like 20 minutes ago or something like that, would have changed the direction or just made it quicker for you guys?
I think probably the only significant shift that we've had has been that we never really wanted to manufacture these robots. We wanted to be the innovation shop. We wanted to keep doing innovation. And through exploring manufacturing partners and the like, we've just come to find out that we need to control it, right? We need to be able to have the quality assurance programs. We need to be able to do all of that. And so I think probably the only thing I may have changed was if we would have started at the very beginning thinking we were going to actually manufacture the robots, it may have taken a little bit of a different path. But I'm not even sure. I've told people multiple times that if I wrote a script of where we've been in the last 5 years and tried to sell it to Hollywood, they wouldn't buy it because it'd be too much fantasy, right? Most people couldn't even believe. Who's going to believe that there's a patent lawyer who used to be in Silicon Valley with an electronics engineering degree that grew up on a farm, lived 3 houses away from you in Aurora, Nebraska?
Pretty lucky, I'd say.
Right? And so, but that's just one of the stories. As everything's just been, we could never replicate it. I just talked to another startup, and they were just asking me questions about our brand and our marketing and our social media and how they might replicate that. And I'm like, I don't know if anyone ever, I don't know if we could, with the timings of the MIT Innovation Award came out at the exact same time that we got the first video you made for us. And yeah, we targeted that. I mean, it was intentional. But some of those lightning strike type things that really have propelled our company, I don't think you could ever replicate again. So as we sit back and look at this, is like on the days that I'm struggling, right? Because I'm a startup CEO. There's a lot of ups and downs and emotional swings and things, and it's like on the worst day, 99.9% of the population in the world would trade places with me.
For sure.
Right? I'm living the dream, and I can't complain about any of it. So I'm not sure that if I could pinpoint anything that I would ever go back and change, just because we have been so, this has been such a tremendous opportunity for us.
Awesome. Well, I think that's a good place to end
All right.
this. Thank you
Sounds
for
good.
having me. Always exciting to come up into the robot workshop and see what's going on. But thank you for having me, and let's see what the future holds.
Thank you very much, and I appreciate everything you've been doing for us.
We're just getting started.